Our final two exercises in the fan test stand lab session will be to record data for two 5 horsepower fans in series. And I'll show you that setup next. But first I need to correct something I said in the previous video with the single 5 horsepower fan. I said that that was the 5th exercise, but actually it was the 3rd exercise. My apologies. As a refresher, we had already done the 10 horsepower fan at low and high speeds. Those were exercises 1 and 2. Then we did the single 5 horsepower fan at low and high speeds, exercises 3 and 4. In this final segment, we're going to do two 5 horsepower fans in series, low and high speeds. Those will be exercises 5 and 6. And also, I want to remind you, we're going to email data sheets to you that are already filled in. So when you see me writing on the sheets, you don't need to write anything down here. You'll already have that. I'm just writing it down in the videos so that you will see what you would be recording and when in the sequence of the lab exercise. Okay, let's take a look at the setup here. This is a long behemoth. So we've kept the original, the first 5 horsepower fan that we saw in the last video is still in place. And then we've added the second one behind it. So the discharge from the first fan is leading into the inlet of the second fan. Okay, I apologize, kind of dark here. It is really long. We didn't need to add any additional wedges under the second fan, which is nice. The duct is a slip fit into a flange of rolled angle iron here, and then we use duct tape to seal that, so that works very effectively. And I wanted to show you also the VFD connections here. Quite a few cables. We've got 2 pigtails here which supply the power from the VFD to the fans. This long cable here is connected to a disconnect back at the far wall there. And then, let's see, where is it? This smaller diameter cable goes over to the speed control pendant on the table there, okay? So kind of a tripping hazard on the far side of the duct there, but there really isn't any reason to go back there. So let me put the camera back on the tripod here. Normally, you guys would have the fun of moving the fans around, and we would remind you to write down millwright skills on your resumes. I guess we can't do that now, but maybe you could be virtual millwrights, something like that. Okay. Here is a partially filled in data sheet for the two 5 horsepower fans in series at low speed. This uses the same flow restrictions as for the single 5 horsepower fan test. That is going to allow you to compare the case of the single 5 horsepower fan to the two 5 horsepower fans, as I'll discuss in just a minute. I'm going to go ahead and activate the VFD. It's set to the same low speed setting as for the single 5 horsepower fan. It will be a little louder since there are 2 fans running, and you probably couldn't even hear the single fan during the last video. While the fans are spooling up to the RPM, I wanted to go over the fan laws again, that analysis, because it's an important objective of this lab session. In the earlier exercises, we recorded data for the single 10 horsepower fan and the single 5 horsepower fan at low and high speeds. So as a refresher, the fan laws tell us that the flow rate should scale proportionally to the speed ratio between high speed and low speed. The pressure should scale with the square of the speed ratio, again, high speed to low speed, and the aerodynamic power generated by the fan should scale with the cube of the speed ratio. So here are some larger scale sheets with those relations. Okay, once again, Q is proportional to the speed directly, so Q2 equals Q1 times the quantity N2 over N1. Q is the flow rate, N is the speed. The units don't matter as long as they're consistent. In our case, Q will be found in cubic feet per minute. N is in RPM. The second fan law is that the pressure should be proportional to the speed squared. So P2 equals P1 times the quantity N2 over N1 squared. In this case, P is the static pressure generated by the fan, That would be inches of water in R units. N is the speed, again, in RPM. The third law is that the fan power should be proportional to the speed ratio cubed. So power 2 equals power 1 times the quantity N2 over N1 raised to the third power. In this case, power is the aerodynamic power generated by the fan. It's not the electrical power consumed by the fan. So that's given by this equation. Power equals P sub S times Q times 0.117, where P sub S would be inches of water, Q is CFM, 0.117 is the conversion factor, and then power will be in watts. Okay, the final laws that we're looking at involve identical fans in series or parallel. So for identical fans in series, the total pressure should be doubled and the flow rate Q should remain constant. For identical fans in parallel, which means they're connected side by side, the pressure should remain constant and Q should be doubled. We're not studying this case, but we are looking at this case here. So what you're going to do is compare the single 5 horsepower fan data to the fan data that we're about to record for the 2 5 horsepower fans in series. And specifically, you want to see if indeed pressure is doubled while flow rate Q remains constant. Okay, so check to see if the fan laws hold in your analysis and be sure to comment on those results. The 2 5 horsepower fans are now spooled up to speed, so we'll take some data points here. Again, we're using the same flow restrictions as for the single 5 horsepower fan that we just tested, so you will be able to compare them at each data point. See if the pressure is doubled while the flow rate is constant. So we're using the data for the single 5 horsepower fan in a couple of different analyses here, both to see if those first 3 fan laws applied and then also the 2 fans in series. Okay, so spooled up to speed, the first test is going to be open, no flow restrictions. Okay. Delta P is 0.311 inches. P sub S, 0.330 inches. Voltage 311.7. Amperage 4.8. Power factor 0.27. Okay? All right, so first data set. So again, I didn't measure the RPM, but it's about 780. I would measure that again at the beginning and the end. You've already seen that. I will write that down though. As was the case for the single 5 horsepower fan, the first flow restriction to go to the box will be M5. Put that in place. Seal the lid. Let the flow equilibrate. Okay, now our delta P, representing the flow rate Q, has dropped to 0.301 inches of water. The static pressure has climbed up to 0.388. Voltage is essentially the same. Amperage is the same. Power factor is the same. Okay, so there is the second data point. Again, the next flow restriction is M4, so I'm going to pull out M5 and put M4 in its place. Let the flow equilibrate. Once again, if you guys were doing this exercise, we would rotate you. We'd have some people changing out the restrictions, some people calling out the data, somebody recording the data, and also somebody measuring the RPM at the beginning of the test exercise and at the end of the test exercise. but hopefully you get the idea of how this is all done. You've done a lot of it already. It's not that challenging, but hard to see remotely. Okay, so for data point number 3, our delta P is 0.283 inches. Our P sub S is 0.484. Voltage is about the same. Amperage is about the same. And power factor has improved a little bit as we're asking more of the fan. Okay? So there is our third data point there. Once again, we'll email you filled out data sheets. This is just so you would see what we're writing down and when in relationship to the sequence of the lab. So we would complete this for the low speed, turn up the speed to the high speed, check the RPM, go through the same exercise, and that would be the completion of the fan test stand data recording. Very good.